Hello, hello, hello. I have switched to YouTube, and today we're going to be talking about a bug that that a user raised on the issue tracker around unexpected join behavior when chaining joins. Put that in the chat. And let's get started. Alrighty. So typically the first thing I like to do is if a person, as this person did, created an issue, and let's see, it was 4309, so 4309. I like to see if they've actually put any code there, and it looks like this person did, which is really nice. Thank you, Brendan Bikes. And you can see that this person wrote MWE, which means minimal working example. So in this case, it's pretty sweet because I can basically just copy this code and put it here as a test. We're in the Backend test suite. You can see there at the bottom of the Vim buffer the path I'm at. At some point I'm going to do a stream on the Backend test suite, but I'm not doing that right now. One sec. Let's see. Okay. So I'm just going to call this test pandas join for now, and then once we sort of reproduce and determine, kind of whether there's a fix, we can see whether that's feasible. All right, so let's just see if this test reproduces. Give me 1 second. Okay. 1 second. Okay. Okay, so this in theory looks like a kind of a self-contained example, right? We're importing pandas, we're importing Ibis, doing a bunch of stuff, initializing tables and whatnot, trying to execute some joins. It looks like expr1 works, but expr2 fails. And expr1 is sort of a kind of a vanilla join, whereas expr2 is kind of chaining some of these joins. So let's just run this test. PyTest, Ibis backends, test join, pi : : the : : in PyTest syntax lets you access a specific test in a file. There is tab completion support for that. I have not set that up. So let's run it. And indeed, it looks like there is some failure in in which line did it fail on? Okay, so it did actually fail on trying to execute the second join. So let's dig around. One thing we might want to do right off the bat is just kind of make sure that the result of executing x per 1 is equal to some, expected 1 thing here. We're just going to import pandas.testing as TM, which stands for testing module. It's a convention writing when using this testing module from pandas. And let's just make a more formal assertion about the result of this join. So the way we do this in Ibis typically is to kind of write the expression by hand in pandas. And so since we have our data frames, we can say test df1, we can call pd.merge test df1 test df2, and it's being joined on ID. By default, joins are inner joins in Ibis, and so we're going to specify that. It looks like that's the default for pandas too. Let's just be explicit here. And then on ID, right? We're saying, quality join on ID, table 1, table 2. So in theory, we should at least be able to pass this test after commenting out the things, because it looks like there's something different about the right hand side. So let's just call this result 1 here so we can look at what that is. Okay, so we've got result 1, we've got expected 1. So it looks like there's some funniness in what's happening here. Sorry, it looks like the stream is private. So I've just now made it public. So we've got different ID columns coming into the result, and that's because Ibis is fairly conservative about what it considers what it considers kind of safe to deduplicate. It turns out that only in the case of an inner join with equality predicates can you kind of ignore potentially the left and the right side and just say, oh, this is the ID column. In every other case, you may potentially have nulls in one side, which can alter the result of sort of which ID column you choose. So that's kind of the result of the difference here. This isn't this particular detail of this part of the test is not super relevant for what we're doing. The fact that there are kind of deduplicated join key columns may actually make a difference ultimately in any solution we come up with. So for now, what I'm going to do is rename let's see, I'm going to rename columns. Let's see, columns ID to IDX. Let's just actually do this up here. Oops. Up here. And then I'm going to assign I'm going to add a new column, which is ID Y, and that's equal to the input data frame dot ID. Cool. And so now we've got our expected 1. In theory, this should pass the test. And it looks like data frame has no attribute ID. Why is that? Oh, because I got rid of ID from the rename, of course. Okay, so let's actually just swap these, and in theory that's enough. Of course. Okay, so the column indices are in a slightly different order, right? So actually what we want to do is put oh boy. It looks like we want to do this. Wow, this is really horrible. I'm going to take the first two columns, which is, I guess, IDX and value X. We'll assign to that basically test df. Oh man, this is starting to get really annoying. Okay. Joined. We're actually going to assign the joined. Let's see. So this will be. I guess we can. We can assign this as well. Oops. We can say IDX. Sorry, IDY equals df IDX. And then we can do another assign, which is value y equal to joined value y. Okay. Whew. Okay, moving on. So we got that test to pass. Oops. And now we want to see kind of what's happening here. So first off, let's take a look at the actual expression, right? And you can see that kind of going from sort of the bottom up, the bottom being the most recent expression or the root, we can kind of go to in reverse topological order from bottom to top, and see what we've built, what expression we built here. Okay, so our final expression is, of course, this join over here on the left. Sorry, on the left pane. And it's, of course, looking at the T1 and T3. You'll notice there are all these like R0, R1, etc. And those are kind of temporary aliases for relations. That's what the R stands for. That indicate sort of basically relational operations in the expression tree. So they don't, I guess the reason I'm pointing that out is because they don't necessarily match the names of the tables that you give. And you can see on many of the sort of the leaf table types that we have, like there's the actual table name, and then there's this like R alias. So we've got our final inner join, and then we have a selection. And a selection corresponds to sort of like roughly to a select statement in SQL. And you can see there's these sort of deduplicated column names, right? We didn't actually select anything out. We just said, hey, I want to select everything from the join. And if you don't actually specify columns from this, you'll get an expression that has every single possible column deduplicated if the columns are overlapping in each data frame. You can specify a suffix. By default, we use _x and _y for the left and right respectively. That comes from, that's a convention taken from dplyr. Then we have our inner join kind of above that, which is what we're testing with the first assertion. And then our leaf tables that are sort of the join, arguments, the left and right sides of the join. So we can construct the expression, which is good, right? Like Ibis, assuming the validation in Ibis is correct, our expression is in some sense correct from the perspective of Ibis. Now, of course, this is not necessarily true for a given backend, but that's why we're investigating this bug. So let's look at the stack trace again. So we're looking now kind of deep in the Pandas execution backend. It's probably worth doing a separate stream on all the different backends, maybe post kind of a big refactor that we're doing at the moment. But again, yeah, for a separate stream. So the first thing I'm going to do now that I've sort of got a reproducing test is like I don't need to print this anymore. I can just assign this to a variable, and we can, you know, kind of look at it later. We're effectively going to make kind of the same assertion, but nothing. We haven't made this yet, and so we're just going to leave that there for now, since it won't, until we fix this, it won't make it past this anyway. So let's dig into this file execution/join.py. Again, I'm going to go to Telescope and Vim, and I'm just going to type join.py, and then we can see that the file is right here. You can do cool things like, even though it's not pandas/join.py, if I type that, it'll come up because it's doing a substring match. And it happens to actually take us right to, you know, the function we're interested in. That's just a coincidence. This is probably the last time I was in this file. This is probably where I was for some reason or another. And we're in this function called construct join predicate columns. One of the challenges here is, if we go back and look at the test, is that this predicate is actually referring to columns that are sort of deeper in the expression tree. Or sorry, it's referring to columns coming from tables that are deeper in the expression tree than, you know, than its child expression. So the join has another join on the left, but in the join predicates we're looking at T1, right? So actually the join, any algorithm that's sort of dealing with join predicates kind of needs to be aware of this. It needs to be aware of the expression structure at a deeper level than just, say, looking at the child inputs. So the problem is kind of like fuzzily related to that. Like, I'm not sure exactly what it is yet, but it looks like it's kind of related to that, because you can see there's a key error when the backend is trying to look up df1, which is the table that or the data frame that kind of corresponds to table 1, you know, t1.id in the test over here. So it's basically trying to execute the join predicate, and it's like, well, I don't actually know where to get the ID column from because I don't have a data frame that corresponds to T1. So as we've done in the past, I say that like it's been a long time, as we've done in 2 Twitch streams, let's set a breakpoint and just start poking around. Oh, we should look at where join predicates construct join predicate columns is called. Perhaps unsurprisingly, it's called in sort of the execute rule. Whoops. It's called in the execute rule for joins, and that rule takes, of course, the operator and the left data frame, the right data frame, and a tuple of predicates. And what this is doing is constructing strings or series for the sort of the left and right on predicates for the pandas backend, or for the actual join that's going to be done. So we are potentially going to hit this call more than once because we have 2 joins in the mix here. So we can look at, say, what the op is. So ops are kind of the internal representation of an Ibis expression, and oftentimes you want to see what the sort of the prettified representation is when you're debugging, and not the raw op representation. We do want to improve the raw op representation because it's a little clunky right now and hard to read. And we don't want to have to be calling 2expr all the time in debugging mode. So we're working on that. But for now, we can see that this is the first join. Okay, so we know this one works. We can skip over it. So I'm going to hit C, which is short for continue, right? Cont is also short for that. So you can type continue. Again, oops, we've got our op, and it looks like we may have hit the second join now. Okay, it appears we're re-executing the first join, which isn't great. There's probably some redundant computation happening here that's unnecessary. And now we're sort of at the final, or rather the second join. So we haven't yet entered the loop. So we have this dictionary. Let me clear the screen, which has kind of the left operation of this join. So if we look at 2expr again on op, our left is going to be the selection R4, and then the right is going to be R0, which is sort of table 3, right? So we can of course do op left, op 2expr, that gives us the selection. Then we can say op.right dot op parentheses 2expr, that gives us table 3 or df3. So basically the problem here, roughly, is that this on is expecting to look at is expected to contain the actual leaf of the join for the left join, when in fact which would be table 1, but in fact it contains the selection and not the root. Sorry, the leaf. So we need to figure out like what the heck is, what is producing this. And I mean, sort of obvious here, I guess, is that it's this function here, compute join column. And you'll see we have this method called root tables, which is kind of strangely, well, at the moment strangely named, and really it should be called child tables, but just kind of going with that terminology for now. Let's see if we can step in to that function when we reach it. Okay, so we're here, and then we want to actually just kind of step in there, hitting S. Okay, so now we're in this function, and we can look at, whoops, oh shit, sorry. We can look at column expr, darn, okay, column expr. That's our left ID column, right, which is the thing that's not actually working. And then we've got column op.name. Okay. We know we can pull out just the string and give that to Pandas, which is a little bit more efficient than handing it like the full series, because it's a table column, and a table column is kind of a simple operation where it's the child table and the name of the column from the child table. And you can see that here, table name. And then from that column, we pull out the root table. There should be only one, and it's going to be, yeah, the thing that that it's going to be basically the child of the column. So let's keep going. Oops, sorry. Where were we? Here. Okay, so this is going to fail, right? Because we don't actually have that. And you can see, yeah, key error, right? So we don't actually have that. So we do now have at least an idea of what's happening which is that we're because the user has specified, the sort of the deeper in the tree table, the pandas backend is kind of expecting that to be in this dictionary as a data source. But what in fact we care about is um, really what we care about is sort of making sure that let's see, what do we actually care about? We care about making sure that the selection that's generated from the join expression is being used instead of the left table. An alternative approach might be to think, well, maybe we actually care about kind of removing that selection entirely, and only caring about the sort of the deeper table, and that may be an approach we ultimately go with, but kind of need to dig around a bit more and see what's happening. Hmm. Yeah, this is a little tricky. I'm not entirely sure how exactly we want to go about this. Okay, let's see. Sort of wondering if actually what we care about is really just left op and right op. We can't do that because even though this is not necessarily the left-hand side expression, right? Because you could have, like, we could have written t3.id equals t1.id, but this would actually be coming from the right table. The left here and the right here refer to the left and right operand of the equals operation, right? They're referring to this left and right of the comparison base class. So we can't do that. Further complicating this is the join renaming an issue. Oh, it looks like we have somebody in the stream that says the thing fails in SQLite as well. Okay, so that's good. I mean, it's not good that it's failing, but it's useful to know because that means we should probably write a backend test suite for this. Sorry, a backend test for this, and not just something specific to pandas. Okay. So another, I guess, way to think about this is to think if whether there's something we can do at the top of the expression when it's constructed to prevent, the kind of the lookup from being done on the left-hand side. This is a bit more invasive change. It would sort of require doing some kind of substitution of the expression tree when during join constructions. But it's not totally clear if that's what we should do or if we should try and isolate this to the various backends that we care about. Um, right. Let's see how the this is being called again. Okay, so the join's coming in. Right. All right, I'm going to have to pick this up in a bit. I have a meeting I need to go to. So I will see everyone next time.